In this video, we're going to try to find this limit. So our function is the square root of x squared minus x plus 1 minus the square root of x squared minus x. A good thing to start with is to find the domain of definition of this function. Okay? So clearly this one is defined everywhere. And this one is defined when x squared minus x is bigger than 0. That means x is between minus infinity, 0, union 1 plus infinity. And therefore, we can find the limit as x goes to infinity. So here, when we try to evaluate this limit, we see that this one is going to plus infinity, because we can enter the limit inside since the square root is a continuous function. And this one is also plus infinity because we care about this power here. X squared goes to infinity, and here x squared goes to infinity, and with the square root we still have infinity, but with this minus here we have plus infinity minus infinity, and we can't conclude. Okay? So here, when we have these radicals, a good way to find the limit is to multiply by the conjugate. Okay, and that's what we're gonna do here. So it's here x squared minus x plus 1 minus the square root of x squared minus x times the square root of x squared plus x plus 1 plus the square root of x squared minus x over the square root of x squared plus x plus 1 plus the square root of x squared minus x. Okay, here we're dividing by this number because it's never 0. Okay, in its domain of definition, this number can never be 0. Try to prove it. It's easy to show. So this number is never 0. Okay, now we can simplify this expression. Okay, we have, using the fact here, for those of you who don't know, using the fact that a squared minus b squared is a minus b times a plus b on the top. So here, this is our a, this is our b. So here, the minus and the plus. So a minus b times a plus b is equal to a squared, this one squared, minus this one squared. Okay, so it's going to be x squared minus x plus 1. Okay, so the square root squared, which is giving us this one, minus x squared minus x. Okay, because this is the square root squared, and in its domain, this one is always positive. That's why we don't have the absolute value. Over the square root of x squared plus x plus 1 plus the square root of x squared minus x. On the top, we get, if we expand, we will get x squared minus x plus 1 minus x squared plus x. Okay, over the square root of x squared plus x plus 1 plus the square root of x minus 1. Here we see that we can simplify. Okay, this one will go with this one, and this one will go with this one, and we have only one. So therefore, this limit here of the square root of x squared minus x plus 1 minus the square root of x squared minus x, as x goes to plus infinity, it's going to be the limit as x goes to plus infinity of 1 over the square root of x squared minus x plus 1 plus the square root of x squared minus x. Okay, and therefore we can conclude now. Okay, we don't need to do any computation, if you see that. So here, this limit goes to infinity, and this one will go to plus infinity, and therefore we have 1 over plus infinity, because the limit of this one is plus infinity, and 1 over plus infinity is 0. Okay, therefore this limit is 0. Okay, and this means that this limit here is 0. Okay, I think that's all we need. Okay, the only thing that we didn't prove is that to prove that this one is always positive. Okay, and that's a simple. It's a bit of algebra to do. Okay, so define the following function: f of x is the square root of x squared minus x plus 1 minus the square root of x squared minus x, and show that f of x is bigger than 0 with x is in the domain of f. Okay, so we need to find the domain. Okay, and you need to prove that f is positive. Okay, and I think that's it. Our aim is to find the limit, and we found it from here, because remember, plus infinity is plus infinity. Okay, so we have 1 over plus infinity. A small number over a huge number is 0. Okay, this ends our video. Thank you very much.